Yes, good morning, everyone. Just want us to start today's lesson. Welcome to class. Last time we looked at chapter 1, chapter 2, chapter 3, and chapter 4. And today I want us to highlight on chapter 5 onward. Today we are going to look at system development life cycle. System development life cycle, SDLC. Now, what is the meaning of system development life cycle? SDLC is a set of activities that the system analyst, designer, and users carry out to develop and implement an information system. SDLC is a set of activities that the system analyst, designers, and users carry out to develop and implement an information system. They carry out to develop and implement an information system. Now, one thing you'll note, these activities are closely related and cannot be separated. When you talk about a system development life cycle, one stage must be completed before the next stage can be started. Now, the stages of SDLC. Stages of SDLC. Number one, we have preliminary investigation or preliminary study. We call it preliminary investigation or preliminary study, where you define your problem. Then you do feasibility study. When you talk about feasibility study, we do a cost and benefit analysis. Then you talk about system analysis. Then you go to system design. After you design, you code. After you code, you do the testing, you do the implementation, and you do the system maintenance. You start by preliminary study where you define the problem. Then you go to feasibility study, cost and benefit analysis. You analyze your system. Then you design. Here it's where you have a logical and a physical design. Then you code with your preferably programming language. Then you test, and here we have different types of testing. We shall look them later on, where we have system testing, unit testing, etc. Then we have different types of implementation. We have the parallel, we have the phased, we have the pilots. Then we have maintenance and different types of maintenance. We shall talk about them later on. Now you need to identify those stages. There are 8 stages, and they revolve around in all the systems. Now, advantages. What are advantages of software development life cycle? Number one, project management. Now, you see, when you break down a project into phases, it has distinct advantages in that each stage can be specified, planned, and evaluated before moving on to the next stage. I'm saying breaking down of a project into phases has distinct advantages in that each stage can be specified, planned, and evaluated before moving to the next stage. That's advantage number one of SDLC. Advantage number two is documentation. Now, SDLC tends to be associated with thorough documentation. You find each stage has its own documentation. Each stage has its own documentation standard and makes the quality assurance process much easier. Then we have disadvantages, inflexibility. Why? Because SDLC has a sequential phases. Now, and it can be inflexible for a smaller system. Again, it's old-fashioned. SDLC is associated with structured techniques, and many of these have been found to be inappropriate for today's modern system. Now, system development methodology. We have different methodologies that you can use when you want to develop a system. Now, a methodology is a formalized, standardized, and documented set of activities used to manage system development. It is a formalized, standardized, and documented set of activities used to manage system development. It is also a framework. It is also a framework used to structure, plan, and develop system. It is a framework used to structure, plan, and develop system. Now, types of system methodologies. Number one, we have structured System Analysis and Design Methodology, SSADM, Structured System Analysis and Design Methodology. Now, what is SSADM? Now, it is a set of standards for system analysis and application design. It is a set of standards for system analysis and application design. It is based on the waterfall model. It is based on the waterfall model. Now, characteristics of structured system analysis and design methodology. Number one, division of project into sub-processes with well-defined objective. There is division of projects into sub-processes with well-defined objectives. Number two, activities are performed in a sequence. Activities are performed in a sequence. And number three, diagrammatic representation and other useful modeling techniques are used. Diagrammatic representation and other useful modeling techniques are used. Now, with structured system analysis and design methodology, a system is represented in form of diagram before translating the diagram into real working software. Now, you need to know when we talk about this structured system analysis and design methodology, there is a division of your project into sub processes. Then activities are performed in a sequence, and you can use diagrammatic representation and other useful modeling techniques. Methodology number two, object-oriented system analysis and design methodology, or OOSADM, object-oriented system analysis and design methodology. Now, it is a software engineering approach that models a system as a group of interacting objects. Object-oriented system analysis and design methodology is a software engineering approach that models a system as a group of interacting objects. Now, each object represents some entity of interest in the system being modeled. Each object represents some entity of interest in the system being modeled and is characterized by its class, its state, and behavior. Each object represents some entity of interest in the system being modeled and is characterized by its class, its state, and behavior. Now, object-oriented analysis applies to object modeling technique to analyze the functional requirements of a system. Object-oriented analysis applies to object modeling techniques to analyze the functional requirements of a system. Now, number three, we have a rapid application development, RAD. Rapid application development, RAD. Now, it is a software development methodology that has minimal planning in favor of rapid prototyping. It is a software development methodology that has minimal planning in favor of rapid prototyping. Now, planning of software developed using RAD is interrevealed with writing the software itself. Planning of software developed using RAD is interrevealed with writing the software itself. Now, lack of intensive pre-planning allows the software to be written much faster and makes it easier to change requirements. Lack of extensive pre-planning allows the software to be written much faster and makes it easier to change the requirements. Now, phases. What are some of the stages of this rapid application development? From the word rapid, very fast. Now, requirements planning phase, that's stage number one. This phase combines the elements of planning and system analysis phase of SDLC. This phase combines the element of the planning and system analysis phase of SDLC. Number two, users, managers, and ICT staff members discuss and agree on business needs, project scope, constraints, and system requirements. Stage number 3, it ends when the team agrees on the key issues and obtains management authority to continue. That is stage number 1 of rapid application development. Stage number 2, user design. User interact with the system analyst to develop models and prototypes that represent all system processes, inputs, and outputs. User interact with the system analyst to develop models and prototypes that represent all system processes, input, and output. We have construction phase. Construction phase. This phase focuses on program and application development tasks similar to the SDLC. Now, in RAD, however, users continue to participate and still suggest changes or improvement as actual screen forms or reports are developed. Then we have the other stage, which is the last stage. It is the change over phase. Change over stage. Now, this phase resembles the final task in SDLC implementation phase. This phase resembles the final task in the SDLC implementation phase, including data conversion, testing, and change over to the new system and user training. This phase resembles the final task in the SDLC implementation phase. This phase resembles the final task in the SDLC implementation phase, including data conversion, testing, and change over to the new system and user training. Now, advantages of RAD. Advantages of rapid application development. Now, 1, there is reduced development time. Reduced development time. And this is achieved by rapid prototyping. Remember, a prototype is a model of a real object, of a real system. Is achieved by rapid prototyping and by using automated tools like computer-aided software engineering tools. Those are the case tools that enable the developer to reuse previously generated code, thus saving the time needed for manual coding. That enables the developer to reuse previously generated code, thus saving the time needed for manual coding. Number 2, advantage of RAD, reduced cost. Reduced cost. Now, RAD involves the use of existing reusable components, leading to lower cost of production. Leading to lower cost of production. Number 3, there is better project management. In rapid application development, there is active participation of the management, the development team, as well as business owners and users, Then we have greater customer satisfaction. Now, the RAD methodology involves active participation of the customer and end users in all stages of analysis and development of the system. The RAD methodology involves active participation of the customers and end users in all stages of analysis and development of the system. Now, disadvantages of rapid application development. 1, requires highly skilled developers or designers. Requires highly skilled developers and designers. Number 2, depend on strong team and individual performances. Depends on strong team and individual performances for identifying business requirements. Depends on strong team and individual performances for identifying business requirements. Now, methodology number 4, joint application development, JAD. Joint application development, JAD. JAD is a methodology that involves the clients or end users in the design and development of an application through a succession of collaborative workshops called JAD sessions. We find there are sessions. Now, advantages of JAD. Remember here we involve the clients, we involve the end users in the design and development of an application through a succession of collaborative workshop called JAD sessions. Now, advantages of JAD. Number one, it is time saving. Why? Because all the stakeholders, remember we looked at different stakeholders, all the stakeholders are usually in the same place at the same time with no outside distraction. And this enables the group to reach consensus on the requirements of the system much faster. Enables the group to reach consensus on the requirements of the system much faster. Now, cost saving. Now, reduced cost is as a result of faster analysis in design process. That is reduced cost, then ownership of the system. Due to the interactive nature of joint application development, all issues and ideas can be discussed, resulting in a system that meets everyone's expectation. Due to the interactive nature of JAD, all issues and ideas can be discussed, resulting in a system that meets everyone's expectations. Disadvantages of JAD. Number one, we have time commitment. All JAD participants must be able to meet at the designated times and will need to suspend all other activities for this period. All JAD participants must be able to meet at the designated times and will need to suspend all other activities for this period. Now, JAD commitment. JAD can only produce effective and productive results if the organization is firmly committed to the approach. Joint application development can only produce effective and productive results if the organization is firmly committed to the approach. Now, factors affecting choice of a system methodology. Factors affecting choice of a system development methodology. Factors affecting choice of a system development methodology. Number one, we have well-structured problem situation with well-defined clear requirement can be handled with traditional SDLC approach. Number two, unclear user requirements can be addressed by RAD. Unclear user requirements can be addressed by rapid application development through prototyping, where a model of proposed system can be presented to the user, in order to assist in capturing and understanding user requirement. Now, system development approaches. We have seen the methodologies. Now, with these methodologies, you can use different approaches. And approach number one is waterfall model. Waterfall model. Now, with waterfall, it outlines the series of steps that should occur when building an information system. Now, the steps usually occur in a predefined order. With review at the end of each stage before the next can be started. The steps usually occur in a predefined order with review at the end of each stage before the next can be started. And stage number one, we have preliminary investigation or problem definition. Then stage number two, feasibility study. Stage number three, we have system analysis. Stage number four, we have system design. Stage number five, system coding. system implementation, and we have system maintenance. System maintenance. Now, advantages of waterfall model. Documentation is produced at every stage of waterfall model. Documentation is produced at every stage of waterfall model, allowing people to understand what has been done. Now, number two, it is linear, meaning it's step by step, and therefore very easy to be implemented. Number three, after every major stage of coding, testing is done to check whether the code is running correctly or not. Disadvantages of waterfall model. If any mistakes happen in any stage, developers may have to start from the beginning. You find it has a disadvantage. You find being linear step by step. One stage is relying on another stage. So if the mistake happens in one stage, you have to start all over again from the first stage. Number two, it is simultaneous, meaning several activities can be done at the same time. Then we have prototyping model. What is a prototype? A prototype is a usable system or system component that is built quickly and at a lesser cost and with the intention of being modified or replaced by full-scale operational system. A prototype is an incomplete version of the software being developed. Software prototyping refers to the activities of getting prototypes of a software application. Now, we have the prototyping process. Stage number one, you identify basic requirements. Identify basic requirements. Now, in this phase, only fundamental system requirements need to build an initial prototype are identified. Stage number two, you develop an initial prototype. Develop an initial prototype. Now, this initial prototype is developed that enables users to interact with data entry, display forms, menus, and input forms. Three, review the prototype. Review the prototype. Customers including end users examine the prototype and provide feedback on additions or changes. Customers including end users examine the prototype and provide feedback on additions or changes. Then we have review and enhance, sorry for that. Review and enhance, review prototype. Then we have the last stage is review and enhance the prototype. Using the feedback, both specifications and the prototype can be improved. If changes are introduced, then a repeat of step 3 and 4 will be needed. We have a diagrammatic representation of a prototype model. Diagrammatic representation of a prototype model. We have the start here. Then after the start, there is requirements gathering. Then you come up with a quick design. You build a prototype. The customers evaluate. You refine the prototype. And here we have the final system. I repeat again. You do a requirement gathering. There is a quick design. You build the prototype. Customers have evaluation, refining the prototype, and the final system. Now, types of prototype, very important. Number one, we have throwaway prototyping. Now, the throwaway prototyping refers to creation of a model that will eventually be discarded, creation of a model that will eventually be discarded rather than becoming part of the final delivered software. You create a model that will be discarded rather than becoming the final delivered software. Now, a simple working model A simple working model of the system is constructed to visually show users what the requirements may look like when they are implemented into a finished system. We have evolutionary prototyping. Evolutionary prototyping. The main goal or objective when using evolutionary prototyping is to build a very strong prototype and constantly refine it. You build a very strong prototype and constantly refine it. Now, the prototype, when built, forms the heart of the system, of the new system, and the improvement and further requirements will be based on it. Then we have incremental prototyping. Incremental prototyping. The final system is built as separate prototypes. The final system is built as separate prototypes. At the end, the separate prototypes are merged in an overall design. At the end, the separate prototypes are merged in an overall design. Advantages of prototyping. Number one, we have reduced time and cost. Reduced time and cost. The added determination of what the user really wants can result in faster and less expensive software. Then we have improved and increased user involvement. It requires user involvement and allows them to see and interact with the prototype, hence allowing them to provide better and more complete feedback and specification. Then we have missing functionality can be identified. Missing functionality can be identified. Disadvantages of prototyping. Number one, we have insufficient analysis or incomplete analysis. It's saying it can lead to overlooking better solutions, preparations of incomplete specifications or conversion of limited prototype into poorly engineered final system that is hard to maintain. And disadvantage number two, there is a user confusion of prototype and the finished system. Then there is developers' attachment to the prototype. We have excessive development time of prototype. Those are the two models. We have the waterfall, the prototyping model. Number three, we have the spiral model. Spiral model. It is an alternative system development model in which the stages of analysis, it's an alternative system development model in which the stages of analysis, design, coding, and review repeat as new features of the system are identified. It is an alternative system development model in which stages of analysis, design, coding, and review repeat as new features of the system are identified. And you can see we have a diagram there. We have the planning stage, we have the risk analysis, engineering and execution, and we have evaluation. Then we have the V model, also called verification and validation model. Now, the testing activity is performed in each phase of software lifecycle. The V model shows software development activities on the left-hand side of the software model, and the right-hand side of the model shows the testing phases activities. And we have our diagram there. Then we have incremental model. With this approach, a model is designed, implemented, and tested until the software is completed. In this approach, a model is designed, implemented, and tested until the software is completed. Then we have the chapter 6. Here we have the system development life cycle stages. We have all the stages there, and I'll be looking at each and every stage at every lesson. We're going to start with a preliminary investigation. Then we shall look at the problem statement. Then remember, with these stages, they will enable you to come up with a software specification requirement document. Then we are going to look at feasibility study, and we look at different types like economic, technical, operational, and schedule feasibility. Then we have rigor. Then we are going to do system analysis. Then we are going to do system design. Here it's where we have logical and physical design. Then we are going to look at coding. After we code, we are going to do testing. After we test, we are going to implement. Then we are going to maintain our system. Note those stages. I've shared these notes with you. Keep on revising. Now we can engage in a forum discussion and quizzes and chats.